Alright, hello everyone and welcome. So in this video I'm going to solve another example where I reduce a linear system of equation into the reduced row echelon form and find the solutions. Okay, so actually this is going to be my second example. In the previous video also we saw an example, but through this example we are going to learn a couple of new things. Okay, alright, so let's get started. The first thing we are going to do is to write the augmented matrix out of this system. So if we look at the coefficients in the first equation, there's no x1, so that means coefficient is 0, and for x2 the coefficient is 1, for x3 the coefficient is 4, and in the right hand side we have 5. So here's my augmented matrix, the first row in the augmented matrix. Likewise, now I'm going to write the entire augmented matrix for the system really fast. So in the second equation the coefficients are 1, 3 and 5, and the right hand side is -2. In the third equation 3, 7, 7 and 6 right hand side. Okay, now we need to do row operations. Alright, so the first thing you need to do is you need to identify the leading entries. So here the first leading entry should be here. Okay, now you can see the leading entry is 0. Okay, we want to make sure that the leading entry here is non-zero. If we can make that happen, we should absolutely do that. All right, so to make the leading entry non-zero, what we can do is actually we can swap row 2 and row 3, right? Row 2 and row 1, excuse me, not row 3. So we're going to swap row 2 and row 1. So I'm going to say swap R2 and R1. So this is an example where you have to use swapping of rows as a row operation. We didn't see such an example in any of the problems that we solved before in previous videos. Okay, so then if we swap, we are gonna get 1, 3, 5, -2. Okay, 0, 1, 4, 5, 3, 7, 7, 6. Okay, right, now our leading entry is a non-zero number, it's 1. Okay, right, so now you might ask, could have swapped row 3 and row 1? Yes, you could also do that. Okay, so as I said in a previous video, so row operations, different people can come up with different row operations, like different ways of doing the row operations. Okay, so it's if as long as the row operation is correct, you're doing the correct thing, you will be fine. Okay, right, here it's easy to swap row 2 and row 1, because in row 2 here I have 1. It's easier to work with 1 instead of other number. Okay, right, it's nice to have 1 in a leading entry. Okay, right, now what we can do is, what we have to do is we have to create that lower triangle of zeros, right? So the lower triangle of zeros would be here, right? This is what we are looking at, right? The triangle that you have under the diagonal of this augmented matrix, okay? Or in the coefficient matrix part of this augmented matrix, we want to make zeros there. So that's how we get the row echelon form, and from there we can talk about the reduced row echelon form later. Right, so to make those zeros, we already have 1 0 here, so it's just a matter of making this 3 0, right? So to make that 3 0, a row operation that we can do is we can multiply the first row by -3 and add it to the third row. Okay, right, so then what we're gonna get is 1, 3, 5, -2, 0, 1, 4, 5. Here it's going to be 0. Okay, so now the second entry, 3 times -3 is -9. -9 plus 7 is -2, so -2 here. 5 times -3 is -15. -15 plus 7 is -8. -2 plus -3 is 6. Positive 6. 6 plus 6 is 12. Okay, right. Okay, now we have 2 zeros. Now it's the matter of making this entry 0, right? So we have our leading entry. Here's our leading entry. It's non-zero. Good. Okay, so we don't have to swap any rows. So here it's just a matter of to make that triangle of zeros, we have to make -2 0, and it can be easily done, right? So to make -2 0, we can multiply the second row by 2 and add it to the third row. Then 2 plus -2 is 0. So 1 3 5 -2 0 1 4 5 0. So 0 here, we're going to get 0. So 4 times 2 is 8. 8 plus -8 is 0. So that's also 0. Okay. 5 times 2 is 10. 10 plus 12 is 22. Okay. So what do we get here now? So if you look at this, we have the lower triangle of zeros. Okay. So this is our lower triangle of zeros. And let's look at our diagonal. So this is our diagonal, but the problem is, okay, so we call them leading entries, but these two are leading entries, but this is not a leading entry. Here, this is supposed to be a leading entry. So the leading entry means the first non-zero number. So the first non-zero number in the third row is actually on the part where you represent the right hand side of the matrix, or the system of equations, actually the right hand side of the system of equations. So we were supposed to have a leading entry here, but we do not have a leading entry here. Instead of that, we have 0. So what does this mean? Okay, so I'm gonna stop here. So what we have here is the row echelon form. Now I'm not gonna go to the radius row echelon form because we have a problem here. We have to address this. So this is the case if we try to, so we have the row echelon form because we have that triangle of zeros. So what I'm gonna do is, if you have the row echelon form, you can find the solution, right? It's not necessary to go to the reduced row echelon form, right? It's an optional thing. So I'm going to stop here and try to find the solution using the row echelon form. So if we try to do that, we can write this system as in the equation form. So it's going to be x1 plus 3x2 plus 5x3 is equal to -2, and then x2 plus 4x3 is equal to 5. That's from the second row. And the third row, you can see it's zeros. Okay, so here I'm going to write 0x3 is equal to 22. Or what this means is that 0 is equal to 22 based on this third row. Think about it. What you have here, okay, on the left side of this dash line, what you have on the left side are the coefficients of the variables. So all of them are 0. So if you add 3 zeros, you're going to get 0. That's what you have here. And then on the right side of the dash line, what you have is the right hand side of the equation, and that's 22 in the last row. And this doesn't make sense. 0 is equal to 22. That doesn't make sense. That's wrong. We call it a contradiction. It contradicts something that we know. Something that we know is that 22 is not 0, right? So this is a contradiction. What we really supposed to get here is an equation for x3, right? Think about this. Instead of this 0, if we had, for instance, 2, that means 2x3 is 22, then we can get x3, right? x3 is going to be 11, then we can plug x3 here, find x2, and then we can find x1, right? It would have been nice, but that's not the case here. Okay, it's not 2 there, it's actually 0. Okay, so in this case, what this means is we have no solution. Okay, we have no solution for this system of equations. Remember, in the very first video of this video series, we learned that for a system of linear equations, it could be the case that there are no solutions. So how do we identify a case where we have no solutions through row echelon form? If you run into this situation. Which situation? Where on the augmented matrix, if you have a row that's bunch of zeros until that dash line, and then if the number that represent the right hand side, let's call it b, if b is non-zero, then this, if you have a row like this in your row echelon form, that means the system of equations does not have a solution. It's a no solution case. So in the previous video, we learned a case where we have a unique solution. We were able to find the solution. But here's an example where we cannot find the solution, but we identify it through row echelon form. Okay, and this makes sense. What does this make sense? Why does this make sense? So if you have bunch of zeros, if you have everything, not bunch of zeros, actually I'm wrong there. If you have everything to be zero, okay, bunch of zeros means, well, some numbers could be non-zero, right? That's not what I meant. What I meant is if you have everything here to be zero, okay, before the dash line, before the point where you separate the right hand side, if you have everything here zero, so I'm going to say every entry is zero, and what you have here, B, is non-zero. And then in this case, every entry here being zero means every coefficient is zero. All the variables are multiplied by zero. So in your linear system of equations, left hand side is zero, and then equal sign, right? And this is right hand side. If it is a number that's not zero, this doesn't make sense. The only case this makes sense is if B is zero. That's why I'm saying B should be non-zero. If B is zero, this makes sense. 0 is equal to 0, right? That's a different story that we'll discuss in the next video. But if B is non-zero, if you come up with an entry, with a row like this in the row echelon form, that means there is no solution for the linear system of equation that you have. Okay, so the way you identify is by looking at your row echelon form and seeing if you have a row like this. Okay, right. So this is just one example. We are going to solve many examples, and we are going to see cases where we have no solutions again. But in the next video, we'll address actually the next case, right? So we address the unique solution case, no solution case. Now let's see a system where we have infinitely many solutions, and let's learn how we can identify such a system through row operations and this row echelon form. Okay, I'll see you in the next.